All right, welcome to Chapter 5, Section 6, Use the Pythagorean Theorem. This is for Math 8. So a couple things you'll see on your screen. So here, the first thing you should see is a due date. I don't see it on my teacher preview, but you'll see it on your student screen. The second thing is the number of attempts. We always have unlimited attempts open, so you can come back into your homework assignments, tests, and quizzes and try them as many times as you would like. Number of questions, that just depends on the particular section. This one only has 4. Grading policy is best score, so whichever attempt is the best one is the one you keep. And partial credit is enabled, so if you answer 1 of 4 questions correctly, you get credit for 1 question, or however many questions you answer correctly. Down here it says, please remember once you start your homework that you must finish it before you can work on anything else. And what that means is once I click start, down in the bottom right corner here, there is going to be a submit assignment button. That's very important. You need to make sure when you are ready to leave the screen, no matter what, you click that button. If you wanted to save your place, make sure that you do have a green check mark on anything that you've started. So don't just type it in and then leave. Make sure you click the check button to get the green check mark so that it'll save your place and come back to where you left off. It stops the program from locking you out when you click submit assignment, and it affects the grade book so your teacher can actually see what you've been working on. Before you click that button, it's kind of like it's frozen. It doesn't let you work on anything else, and your teacher can't see it. So just make sure, good habit, click that button. On the side here, sometimes we have the calculator, kind of depends on what we're doing. And in this case, we're rounding to the nearest tenth, so they're giving us a calculator. We always have explanation, example, and message. So explanation will literally explain the current problem to you, so you're going to lose your current question attempt because it's not going to give you the answer and then let you come type it in. You're going to have to come in on another attempt to try that. Example will show you an example very close to something you're looking at. So we have another little diagram kind of similar to what we're looking at, and it'll walk us through how to do that and what it wants us to do. And so once you're happy with that, you can click close. You can click another example if you'd like, and then you can also message your teacher directly from the screen so that they know where to come help you. All right, so we're still using the Pythagorean Theorem. We learned all about that in Section 5. And so with Pythagorean Theorem, if we have a right triangle like this, then we have the sides that create this 90 degrees. So these two sides here, these are A and B. Does not matter which one is A and which one is B. What does matter, very, very important, is the C. And the C has to be the one that's across from the 90 here. It's the largest side. So the A and the B are the two smaller sides, and the C, which is the hypotenuse, is the larger side. And what Pythagorean Theorem tells us is that A squared plus B squared, so the two smaller legs, are equal to the larger side, and they're all squared. So A squared plus B squared equals C squared. So we're going to use this, and we're going to use it on a diagram just like we see here. So the length of the shadow of a building is 27 meters. So here's the shadow, 27 meters. The distance from the top of the building to the tip of the shadow, so the top of the building to the tip of the shadow, is 35 meters. Find the height of the building. So they have that question mark there. That's what they want us to find. And then round your answer to the nearest tenth if necessary. So we might round, we might not round. So in this case, if we're looking at this piece, 35 is going to be our hypotenuse, our C, and 27 is going to be this B on the bottom here, right? So what we're looking for is the height, which in my diagram is the A. So we have A squared plus B squared. Instead of B squared, I can just replace that with 27 because I know that's the length of that bottom one. And that's going to equal C squared, which we know what C is also, it's 35. All right, so now we're going to go ahead and pull out the calculator here. So we have 35 squared, and we get 1,225, and that's going to equal A squared plus, what's 27 squared? Whoops. 27 squared equals 729. All right, now I want to get A squared by itself, just like I would any other variable. So I'm going to subtract 729 from both sides. Let's see, we get 1,225 minus 729. So we get 496 equals 729 minus 729 cancels. So we get a squared. So now this is the point where we need to take the square root of a number. So remember square root, I talked about this quite a bit in the last section as well. What a square root means, if I'm squaring this number, it means a number times itself will give me this number. So in this case, for a squared, it could only be a times a. So if I want to know what the square root of it is, I'm saying what number do I multiply by itself to get this number? Well, I'd multiply a, so the square root would be a. So I want to do the same thing with 496. As long as this is highlighted and I click this button, it'll work out nicely. It'll put the square root where it's supposed to be. If the number wasn't highlighted, it would actually put it after, like this, and we don't want it after. So just make sure it comes before the number, and then we'll go ahead and equals. And we are going to need to round because this is definitely funky. So we want to round to a tenth, so I'm going to delete everything. I want to go one past the number it's asking me to round because I need to look at this number. If it's 5 or bigger, I'm going to round up. So I'm going to round the tenth up, not the 7. The 7 tells me what to do. I'm looking at the 2 to determine, am I rounding the 2 up or am I leaving it 2? So since 7 is 5 or bigger, I'm going to round this up to 3. So it's going to be 22.3 meters tall. All right. Next. So we're going to do the same thing. Oh, this one looked just like the example we looked at a minute ago when we clicked on example. So now I have an 11-foot ladder. Here's a ladder it's leaning against. That's a pretty crazy angle for a ladder. I don't know if I'd trust that. An 11-foot ladder leans against the side of a house. The bottom of the ladder is 7 feet away from the side of the house. So that seems pretty dramatic. I don't know if I'd trust that ladder, but we're going to go with it. It says, how high is the top of the ladder from the ground? If necessary, round your answer to the nearest tenth. So again, we're going to do the same thing. We have A, B, C. Remember, C is the one that matters the most. It has to be the one across from this 90-degree angle. A and B can kind of flip-flop back and forth. It's not really a big deal which one is A and which one is B. So we're going to go with A again. Why not? A, B. So B is 7 and C is 11. So I have A squared plus 49 equals 129. And then minus 49, so I'm getting A squared by itself. 49 minus 49 cancels. So then we have, and I'm just going to go ahead and start typing this guy in because I have a feeling we're going to have to round. Yep, 72 is not a nice square. So again, if I take the square root of A squared, that's A times A, so the square root is just A. A multiplies by itself twice, or multiplies by itself to get A squared. 72 does not have a nice square. I already know that. So I'm going to go ahead and click this and see what we get. And it says round to the nearest tenth, so I'm going to cut off up to 100th. Since it's 5 or bigger for the number after I'm rounding, this is going to round up to the next number. So it's 8.5 feet. It's resting at 8.5 feet above the ground. Check. All right. And this is also something that we call indirect measurement, because sometimes things are so tall or have such large measurements, it would be very hard to just take a tape measure out and start measuring these things. But if we know the measurement of certain pieces, I know how long the ladder is, I can measure how far away it is on the ground pretty easily, then I can figure out how tall it is, up the side of the house, things like that. So we call that indirect measurement. Let's see. So use the information given in the figure to find the length of BD. So they want this whole side here. So let's see. I'm going to draw this. Ooh, that was not very nicely drawn. So we have A, D, C, B, like that. And then we're given some information here. AB is 20, AC is 13, and CD is 5. All right. So we want the measurement, and I'll put this in bright green here. We want the measurement of BD. So this whole green side, that's what we're aiming for. And remember, I think we looked at this a couple of sections ago. they had something like this, and they might even highlight it for us so we can see it again here. Oh, look, now they have a different one. So now this is the one that I was hoping they would have had, I think on the previous section, where this is a triangular prism instead of just a triangle that has multiple triangles within it. So that's all right. I'll figure it out here real quick. Let's see. So I'm going to airbrush just for a second, and I'll go with yellow. So we have this smaller triangle here, like this, and then we also have the entire triangle like this. So if you notice, it kind of takes the place of both. So this one down here is kind of that funky orange color, but then the pink is the whole thing. So it turned into orange because yellow and orange, or yellow and pink make orange, right? So that's kind of why it mixed together to make the orange. So we have two triangles. So we can do this where we're going to do Pythagorean Theorem more than one time. So we can use this bottom triangle first. Oops. Let me change that color. Like this. So I'm just going to rewrite this bottom triangle like this. So we're going to use Pythagorean Theorem here to find this piece, this AD. Once I can find this, the bottom of the triangle, and I'm not doing real great with drawing these triangles over again, this, so B, A, D. Well, once I know the bottom of the triangle, I can fill it in on this one too, and I already know that this one's 20. So I'll have two pieces filled in here as well, and these are both 90 degrees. So then I can fill in BD, which is what I'm looking for. So it's expecting us to use Pythagorean Theorem more than once here. So I have A, B, C. C is this one across from that 90. So A is going to be my question mark, so I'm just going to call it A squared for now, plus 5 squared, because that's B, equals C squared, which is 13. So A squared plus 25, 5 squared is 25, 13 squared is 169. I'm going to subtract 25, and I think we've actually ended up with one just like this just a few minutes ago. 25 minus 25 cancels. 169 minus 25 is 144. And then I'm going to take the square root of both sides. So I have A equals, and if you don't know, you can always come over here and go square root of 144, but this one will come out nicely. It's 12. So this is 12, so that means this is 12. They're both AD. They both share this bottom line. Okay? So now I can go through, and I'm going to do this I'll do it in bright blue here. So now I have A, B, C. So now A is 12 squared. B we don't know, so I'll leave that B squared. And C is 20. So now I have 144. We just did that, so I'm just going backwards to the 144. B squared equals 20 squared is 400. We've done that one a couple of times here in the last couple of videos. So 20 squared. And then I'm going to subtract 144 from both sides. That's a 4, not a 9. So 144 minus 144 cancels, and I have B squared equals minus 144. It's 256. Ooh, this one's going to end up nicely. So if you don't recognize it, that's okay. I know that 256 is a square. So the square root of B squared is B. The square root of 256 is 16. And this is what we were looking for. So we had to do both pieces to get to this one. So BD, the whole length here, is 16. Oops, I want to type it here, not there. 16. Check. All right, let's do one more. All right, let's see. Okay, so when you're looking at a triangular pyramid, it's formed from 3 right triangles here. So we have these 3 triangles in the back that form a right triangle, and they want us to find the length of SU. And we did this almost exactly the same one, if not the only difference with this between this one and the one we did for section 5 is the numbers change a little bit. But we did this exact same one in section 5. So with this one, and if I view, not explanation, sorry, if I view example, Oh, darn it. Now it's showing me a different one. So I'm going to go back to problem number 3 really quick. And I'm going to use this because I like this diagram they show us here. Oh, they're not showing it to me again. Maybe I just need to click on it a few times. They showed it to me the first time we looked at it. Now they're not showing it to me again. Darn it. Well, all right. I guess we don't get to see the diagram. Let's see. If I click on it a few times, sometimes it'll give me new diagrams. Nope, still not doing it. Okay. Well, we'll do it without that diagram. Kind of was hoping to see it, but what they'll do sometimes is they'll actually show you the triangular pyramid with the different triangles highlighted. It's kind of a little easier to see when they're highlighted different colors like that. So let's see if I can grab this and bring it over here. That. So again, we're still going to be using Pythagorean Theorem, and we're going to use it more than once. So if I use my little highlighter tool here, and I'll go yellow. So we have kind of, let's see, can I get more? Where did my, oh, airbrush. Sorry, I was trying to get it a little bit more specific. So we have this triangle here that I'm kind of coloring in the orange. My airbrush isn't working super well when I do the finer tip on it, but that's okay. So I have this piece here, and we want SU, which is, I'm going to show, we want to know what this length is here, this red length. We also have this triangle here on the side, and then we have another triangle down here in the bottom. Oops. See if I can do that a little nicer there, like this. So we have 3 different triangles we have to deal with. There's also this triangle on the very front, which would be the entire front, like if I could close this box up and you wouldn't actually see it anymore. So like this entire front is also another triangle here, like this. Okay. So, and when I close it up, it hopefully kind of helps you picture a little bit more. It'd almost be like a cover. You wouldn't be able to see into the box anymore. Okay, so it's like a box that looks like a triangle. With this one, what we want to focus on is which one of the 3, if we're ignoring that front one, which one do we have 2 sides on? So if I look at this one here, and I'm going to change to my pen. So if I look at this one here, this blue one, ooh, that was really ugly. Line. Let's try again. Close enough. So I have 11 and 61. I can easily fill in that piece there. Once I have that piece filled in, now I can kind of switch my gear over to this triangle here, and I'll have this piece, and I can easily fill in the piece we're looking for. So we're going to use Pythagorean Theorem twice. So now we have our plan. So let's go ahead and look at this. So we have 11 squared plus b squared, because we're going to go with a, b, c. And that equals c squared. So let's see, we're going to go back to our calculator here. So we have c squared, which is 61 squared. Let's see, we get 3,721 equals 1121 plus b squared. We're going to subtract 121. We get 3,600. So b squared equals 3,600. And now we're going to take the square root. So b equals, let's see, what's the square root of that guy? 60. So this is 60. So now I can change this up, and now I have a, b, c. So now I have a squared plus b squared equals c squared. A squared plus 3,600, we just did that. I'm just undoing the square root here, just going back to 3,600. 100 squared, remember when you're multiplying by like tens or hundreds, you're basically kind of counting the zeros and putting them all together. So 100 times 100 would be 4 zeros. So there's 4 zeros here. I don't know if that necessarily makes sense to everybody, but That's kind of how I remember how to multiply them together. Is it tells me how many zeros I'm going to have in front of the 1. So we have 10,000. We're going to subtract 3,600. 3,600, and I did not line that up nicely. A squared. 36 minus 36. 3,600 minus 3,600 cancels out. And we're just going to subtract 3,600. So we get 64. Well, even though 6,400, 64 does have a square root, so I'm also under the assumption that 6,400 does because it just adds zeros. So yep, it's just 80 now. I take the square root of this. A equals 80. So I had to do both pieces to get from what I have on the bottom to the second one. So I actually ended up ignoring this green one completely. I didn't really do anything with this green one at all because I didn't need to. So this one's 80. Check. All right, so that was section 6. I will see you in section 7.